Good afternoon, one and all. In the last lecture, we discussed about the phases of a compiler and the differences between compiler and interpreter, and different phases of a compiler, such as starts from lexical analyzer, syntax analyzer, and semantic analyzer, intermediate code generation, and the code optimization, and the last phase is the code generation. So these are the 6 phases of the compiler. We have discussed with an example with this one in the previous lecture. Now in this video, we are going to discuss in detail about the compiler, first phase of the compiler, that is a lexical analyzer, and what is the role of this lexical analyzer in part of the compilation, that is compiler phases. And then we'll give a short brief note on that buffering mechanism, that is input buffering, and then how the buffering mechanism or types of the buffers we are going to do the discussion in this one. So first, initially we are going to describe the several phases of the compiler, recognition of remembering the words, that is terms, that is first phase lexical analyzer. So we already know the lexical analyzer as a part of this one. So here in the first phase of the lexical analyzer, source program is given as input, source program which is taken as input to the first phase of the compiler, that is called as lexical analyzer. It is called as lexical analyzer. This is the first phase of the compilation, and this gives the output as output, that is tokens. This is called as tokens. So accepting the input from the source program, which contains sequence of instructions, that is written in programming language such as C, C++, Java, etc. So which is in the high level language, that is human understandable user written language, English language statements. All the statements can be considered as a source program, and this is given as input to the first phase of the compiler, that is the lexical analyzer, and generates tokens. So this part, how the lexical analyzer internally computes the process of this delivering of the token, compute the process of the token delivery. That is the scenario. We already know it is a first phase of the compiler, because compiler contains total 6 phases. First phase is lexical analysis phase, and it is several other names are also, it is called as scanner. Why? Because here we are going to read the source program, entire source program from left to right. Each instruction, character by character, each instruction, character by character, from left to right. Each instruction can be read processed. So this is a scanning. Scanning means reading the characters. How to read the characters? Each character by character. Suppose for example int. So first it will read I, and then N, then T. So left to right mechanism, and the character by character. First time I, second time N, third time T. So that's why all the instructions read from one to another. So this process is called as scanning process. So that's why the name is given as scanner. And lexical analysis, and also linear fashion, done in the format linearly, one after the other. So that's why it is called as linear analysis. And some of the tasks it can be performed. First task is whatever the source program that is given for that compiler, that is to be read as character by character, and then the delivering of the token. So here in this one, previous we have discussed what is the input is given to the lexical analyzer. So it is given input is source program. What is the source program? That is program contains set of instructions. All the instructions is in like English language statements, user written language, C, C++, Java language statement. So we are going to take that instruction step by step, character by character, and then delivers. What is the output? It is delivering tokens. So in the previous slide, previous discussion, one token means the stream of characters that is lexemes identified by this lexical analyzer and generate. So that is the main agenda process in this one. So while reading the characters, suppose for example any spaces like white space, blank spaces, new line character, any other blank and tab are new line characters, and comments. Comments are also we can return to understand the functionality of the purpose of the function or the task that is given for a program. What is the calculation part that is to be understood easily by the developer. So that's why here we are going to write some comments. For example, in the C language, hash slash star slash star, two-line comments, the multi-line comments, slash double star in Java language. So like that we can add some characters as a line of comment. So that is not required for the execution of the program purpose. So in this one, while calculating this lexical analysis space, this input is to be read, but while reading this input, it ignores it ignores ignores or skips the remaining that is like blank. For example, int a comma b. So here in this example, for example, I am reading the character by character int. Then after that, a space occurred and then followed by a letter a. So here the space to be, this is called as space. So this is to be ignored by the compiler. Ignored by the compiler in the lexical analysis phase. Ignored by the compiler in the lexical analyzer phase. So this is not required to consider the, even if they consider that is not part of the output of the program. That's why while it is a button to the compiler where which is required, that is only we can take as this part of this lexical analyzer program. So that's why my main step is to include the characters which are really required for the execution of the program and which are not required, unnecessary comments or spaces, any other lines which are not required really for execution. Those are to be skipped or ignored by the compiler. And another important step is whenever the execution takes place, each phase of the compiler reporting some sort of errors to the error handler. So that is to be reported with some error mechanism, that is like file number and column number, line number and column number. So suppose for example we are executing a program example.c program. So for this C program any error occurs. So it displays line 2, column 14, semicolon missing. Semicolon missing. So this is the format that is to be displayed. So depends on the compiler to compiler, the sort of error messages are displayed. But while displaying the error messages, you should rectify that. You should read understandable by the user. What is the corresponding file name? File name is example.c, and what is the line number? That is line 2, second line, and what is the column number? That is column 14, and what is the error message? The description, semicolon missing. Like that, it is to be delivered to the user, so that the user can understand easily and rectify the corresponding errors and going to the line number corresponding, and if at all the semicolon missed, then it automatically rectify that one, and then once again the compilation process starts, and this time the lexical analyzer doesn't throw error because the semicolon is available. So that's why it is going to the other part of the phase of the compilation process, and then it reads. So here the main important one is we have discussed about this 6 phases. First phase, second, third, fourth, fifth, sixth phase of the compilation process. Lexical analyzer, first phase, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, code generation. So these are the 6 phases of the compilation process. In this compilation process, any variables or identifiers, constants or function names, if at all used by the programmer, that is to be referenced in the symbol table. So symbol table is the one data structure which is used to provide the necessary information to each of the compiler. So this is the reference to. At the same time, while running the delivering the output of each of the phase of the compiler, each produces a different types of output. For example, if you consider lexical analyzer, it generates the output of tokens. Syntax analyzer, if you consider, it generates the output of the syntax tree. Semantic analyzer generates the modified, updated syntax tree. And intermediate code generation, it delivers the optimized intermediate code. Code optimization generates the optimized code. Code generation finally generates the machine code, which is targeted code that is actually required for the machine to deliver the output. So while executing these outputs for all the phases, any errors occurs at that time, then it is reported to error handler. So error handler also plays an important role for each of the phase of the compilation. So that reporting the process while delivering the tokens, any sort of errors occurs. So that is to be encountered. So that is the two things here. One is error messages. Second one is symbol table. Symbol table information is described. That is what information here it is described in the symbol table means the corresponding names of the identifier, constant values. For example, we declare int a. So the variable a is declared inside the symbol table with some sort of the reference number. And for example, constant, if you declare some pi equal to 3.14. So that is to be mentioned as pi with a value of 3.14. Like there's some sort of the information which is really required inside program statements that is to be computed, really required for the execution of the program, that can be taken as a reference inside the symbol table and takes that parameter value and then go to compilation part with the execution of the program. So in this way, this information is required, both symbol table and error handler, to store the corresponding identifier names and value names, and then constants values, whereas error handler is to be represented to report the information. The block diagram representing the lexical analyzer. So here we have already known that it is the first phase of the compiler and this is the second phase of the compiler, and here the source program instruction that is given as input to the lexical analyzer, and the output that is generated here is tokens. Output that is generated is tokens. So here the program given to the input lexical analyzer, accepting the program that is required given by the user, and then generating the token. So how it will generate the tokens in this mode of the process. For here the symbol table also we know that it is a required one which is to store the referential information. Based on that, it accept the identifier values and then give the link mechanism to that one. So while retrieving the special token, this one, it uses a command called get next token. Get next token is a method that is sent by the syntax analyzer to the lexical analyzer. So what is the token that is delivered by the tokens syntax analyzer? Syntax analyzer accepting the tokens, and then it requests one more token based on the program statements. Till the all tokens are completed, it verifies. So the program execution continuously run until all tokens are to be completed. So first token is to be read, then second token. So for example, int a comma b. So for example, here the I and t is read, then the corresponding token is to be released. After that, it is sent to the syntax analyzer and it omit the space, ignoring the space, and then it sends one more command. What is the command name? Get next token. This is the method name. Once again it sent. What is the here? A. Once again it will read. Then what is the next token? Comma and then B semicolon. Like this, the each of the statement instructions one by one. So we can say that it is a difference between your lexical analyzer part and syntax analyzer part. Reading the tokens and then ask one more token until completion of the last statement in the execution of the instruction. Then the loop is to be completed, and then it starts. So here this is the analysis of which is done by this diagram. Accepting the command, that is get next token. This is the method which is sent from the parser to the lexical analyzer. Why? Because it reads the tokens, then after reading the token, once again it is verify any other tokens are there in this from the lexical analyzer. So that's why syntax analyzer repeatedly sending this method get next token, receiving the tokens and reads all until finds the next token. It repeats until finds the next token. So repeatedly execute all the taking the statements and given. So then finally what are the tokens that is released, that is sent to the parser. So in this way the blood diagram can be worked out. So why we are going to differentiate both the lexical analyzer and syntax analyzer? Can't we combine both the phases into single phase? Is any difficulty is there? Yes, there is a difficulty if you can't separate both the lexical analyzer and syntax analyzer. First step is design of the compiler to be, when you consider the design of the compiler, if you do not separate the two phases, then it will be very difficult to the compiler design process. And second important one is the efficiency of the compiler is to be improved. And third most important one is portability of the compiler is also enhanced. Here the first statement will simplify the design of the compiler. That means whenever we separate the both the lexical and syntax analyzer, lexical analyzer automatically do some type of tasks. That means accepting some input, reading the source program and generating tokens. Reading the source program instruction and generating tokens. So the task is reading the source program and generating the token. Reading source program, generating tokens, that is the task. Whereas syntax analyzer task is reading tokens. That means whatever the token that is released by this one. This syntax analyzer is read the tokens and generate the past. Here it verifies the tokens are to be delivered correctly or not, and then based on the tokens, past is to be delivered. So there is one of the important point here is the separation of the phases are not required, because reading all the instructions character by character is a lot of for a programmatic task, and then lot of involvement is there, because sometimes the program carries several number of lines of the code. If the program complexity is 10 lines, 100 lines, 1000 lines and 10,000 lines, like that lines of code is increased, then automatically the lexical analyzer burden is to be more to be occur onto the first phase of the compiler. So and they have to separate the tokens and delivering the token. That is itself a so the design is to be complex if not combined. So that's why one of the main important tasks is we are going to use this design. So we are going to, if it is a single phase, that's what fact here is more burden. It means lexical analyzer, syntax analyzer, if you combine together, then there is definitely more burden on the compiler. More burden on the compiler stuff. So why? Because reading the characters, releasing the tokens, this reading characters, reading source program instructions, that is first task. Releasing tokens, tokens to be released correctly, verifying whether the tokens are correct or not. Verification of tokens are also important. Verification of tokens, that is also one of the tasks. Another one is past generation, that is also one of the important. So these are all tasks to be done by a similar one. So at a time stage it is very difficult. So there will be a lot of burden onto the compiler phase, first phase of the compiler, that is both combined. So that's why it is better to reduce the task of the each and individual and separate both. And one of the other important one is efficiency of the compiler. That means here, to recognize the patterns or lexemes tokens, internally it uses a notation that is called as regular expression notation. We already know, all of you, we know that a finite automata, how the characters to be read from the starting state, initial state, and the output that is to be produced at the end of final state. So this is the process which is to be implemented in case of automata notation. That is, with the help of this automata only, it recognizes the corresponding expressions, and then context-free grammars are also to be implemented. Here in this one, it takes whether the grammar is that correct or not, and based on past generation, it decides whether the that means construction of parse tree, syntax tree, that is to be recognized, and then push down automata also can be used. Um, so internally, to recognize the tokens and verifications, the grammar and finite automata takes an important role. So all these tasks can be bundled together, can be done, is a very difficult task. That's why the separation of the phases is required. And third important one is portability of the computer. We already know portability of the computer. Here, portability of the compiler is to be enhanced. The program which is running can be work on different platforms. Why? Because here the input that is supplied by the user for a corresponding program that automatically worked for several other programs, several other device specific information to be applied. For example, if you applied the character value, data type, character values, integer values for particular specific for specific input and specific platforms, that is to be the program to be worked, carried out the same results with another platform with specific features, other platform specific features, so that the output can't be varied. So in order to get this task, the portability is to be improved. So in order to increase the portability of the compiler, the separation of the phase is to be required. So another important one is here token. We already know that while delivering the tokens by the lexical analyzer, it takes some format notation, that is token name and attribute value. So one example we have considered previously, where we can identify the token names, how can identify the lexical unit is nothing but a token name, and the corresponding value means it is to be mentioned in the symbol table, in the symbol. So in previous slide we discussed, before that we discussed about symbol table representation. It is a data structure where the references of the data items, the identifiers, constants to be stored. So this to be notation is to be used for the particular value of that particular attribute, and then recognize that it is an token name and the corresponding value. So in that way, tokens are to be represented with some specific syntax structure, token name comma value. So for example, here we know that lexeme is a sequence of characters in the source program. Source program contains set of instructions. So what instructions means? So for example, void main, the one instruction. So in sequence of characters, it will read one by one, V, O, I, D, like that it will read, and then form a lexeme and then display to the user. For example, here we have taken an example, E is equal to MC square. E is equal to MC square. In this exponential operator, we have to find out what are the lexemes and tokens. So for example, here lexeme first letter, that is here left hand side is one symbol, that is E recognized, that is a lexeme, and inside the symbol table it stores some data structure type ID 1. Why? Because this ID is nothing but identifier. ID is nothing but identifier, that is also called as variable, and the value. So here the syntax is given as token name or attribute name and the corresponding attribute value. So here, what is the name? Here first ID. So it is an identifier, and in the symbol table it is the first identifier. That's why we are giving a variable name, value of the identifier is 1, since it is the first identifier. In the second one, that is equal to, it is also considered as another lexeme, and it is comes under operator. And the third one, that is M. So here M is considered as one more lexeme, and here it appears as second time. That's why identifier comma 2. So short form we are writing as identifier as ID. Short form we are writing identifier as ID. And then the M appears as a second. That's why ID comma 2. Whereas next character, that is to be read, and then it recognizes one more lexeme, that is star. It is called a multiplication operator. And next more further character C, that is to be identifier. So here ID comma 3. Why? Because ID 3. Here ID comma 3. Third identifier. And then exponential operator is one more that is recognized as operator. And for operators, no need to write the value with the syntax only. And the numerical constant 2 is to be recognized, and it is a constant. Like that, semicolon, last one, E is equal to square, semicolon. Semicolon is also recognized one more lexeme. And then, so like this, the tokens are to be separated character by character and identified by the lexical analyzer, and releases all the tokens one by one, and put the sum of the information in the symbol table, and releases these tokens to the corresponding further unit of that is phase of the compiler, that is called a syntax analyzer. Syntax analyzer accepts these tokens and release the further pass. So patterns used to be identified in formats such as what is the notation to represent this pattern. So generally we already know string is nothing but it is a acceptance of set of characters. So set of characters with the corresponding symbols. So what are the things which are to be recognized in this one? For example, if you are writing a keyword integer, if conditions, else. So these are called as different keywords. And the token name and value which is associated with this one by finding it is the lexeme. So identifier also recognized with some set of rules. And here L stands for letter and D stands for digit. So we can write a combination of the letter followed by R, or a vertical symbol represents R, underscore. That means this letter may be lowercase or uppercase. The letter may be so lowercase A to Z, uppercase A to Z. Followed by, you can also write the uppercase, lowercase and numerals, and then underscore. So it is some form of the rules to be associated while recognize the patterns, and then based on this whether it is a valid identifier or not. So then tokens are to be displayed and generate the pass to the next phase of the compilation. One of the most important topic is input buffering. How the character by character, that is reading mechanism inside this lexical analyzer phase. So here we already know the first main task of the program lexical analyzer phase is reading the source program character by character and release the stream of tokens. So here how the reading information takes place inside this lexical analyzer. Inside the program, it uses generally two pointers. One is called as a lexeme begin pointer and a forward pointer. These two pointers are to be kept, and so that the reading or scanning of the characters from left to right takes place, and then recognize that the corresponding is a lexeme or a valid identifier, something like that. So here, actually the program, whenever the program is, one is compilation and second part is execution. So at compilation part, the program is stored in hard disk. whereas execution it resides in memory. So the program up to compilation, it is in the hard disk, and then reading, while executing, it is in it to execute the program, it must be in the main memory, and then we can start the process of buffering mechanism. Here we already know two pointers. One is legsim begin pointer and second one is forward pointer. These are the two pointers which are to be used inside this buffering mechanism. So first, initially we are going to keep these two pointers, this legsim begin pointer or begin pointer. Legsim begin pointer means it is a beginning of the pointer which is described at the start of the legsim. That's why it is called as legsim begin pointer. And forward pointer is a pointer which is forwarding one step ahead towards the right direction. So initially both the pointers will be placed at the beginning of the starting of the first character of the string. So here we described, suppose int I comma j. So what is the first character? So this is the first character. So these two pointers, legsim begin pointer and forward pointer, these two pointers can be kept at the beginning, and then starts the buffering mechanism. That means here buffering mechanism, the first thing is reading the character. First, what is the character? That is to be I. After reading I, then it moves forward pointer one character ahead. So then n is found. After reading n, then it moves the corresponding pointer t. Whereas beginning pointer at the same place only. Legsim begin pointer kept at the same place only until it identifies the corresponding legsim. So here, every time if you observe the I, after reading it moves to n, after reading n then it moves to t, after reading t then it moves to the pointer at the next character. So here next character is space. Whenever space is encountered, automatically it ignores the corresponding space for the compilation part and moves one more legsim. Then here, after recognizing it is a space, then legsim identifies that it is a token, whereas what is the legsim, it is to be identified and then recognized, placed in the symbol table. So this is the mechanism which is to be used in buffering to read each and every character, recognizing that it is the token and then release the corresponding tokens. So here one pointer is moved ahead one pointer. Which one is called as forward pointer, and eliminates and ignores any of the white spaces. So here, for example, the first two pointers are there at this place. After recognizing the token, then white space, after white space, it recognizes that int is a token. Then the immediate next pointer, both the begin pointer and forward pointer will be set, and then once again read the corresponding character. Like that until space found. Until space found, it reads all the characters, and after the space encounter, it recognizes that the valid identifier is encountered token and release the token, and then once again the setting the pointer. So always this forward pointer moves one place until the white space found, then it releases the tokens. Both pointers are to be set aside. So that, like that, the character is to be read and then read from the secondary storage. So that is one of the main problem with the input buffering is here reading the characters. This one, while reading this one, it uses a notation that is called as system call procedure. So here it takes a long procedure, and reading every character and coding, that is very difficult. So that's why there are two methods are used. One is one buffer scheme, another one is two buffer scheme. One is one buffer scheme, another one is two buffer scheme. So sometimes you have to read that block of data and then send to the buffer. Then using a system call procedure, every time reading this character by character is a very lengthy procedure. One of the most popular techniques are to be used one buffer, and second one is two buffer scheme. So in case of one buffer scheme, whenever the placing all the characters inside the buffer and store the string after reading entire thing. For example, here the contents or cell which are available in the buffer is to be completely filled. Completely filled. That means there is no empty cells inside this buffer. Then we have to it once again goes to the first of this one and overwrites the corresponding characters and then do the process of this recognizing the tokens. This is the one of the drawback of this one. So the length of the lexeme, that means the characters which are available is more compared to the buffer size. Here buffer capacity is very less and length of the lexeme is more. So in such situations, it is going to override the contents of the previous existing contents are to be overwritten, and then once again the recognition of the tokens takes place. So in order to avoid this one, a two buffer mechanism is to be implemented. So here in case of two buffer mechanism, what happens? We are going to overcome the problem of one buffer. What is the problem in one buffer? Whenever the length of the lexeme is more than the buffer size, then the contents are not to be inserted into that buffer. So we have to override the existing contents and recognize the tokens. So then to increase the length of the buffer, we have to use a two buffer technique. Here in two buffer technique, the problem which is arised in one buffer, that is to be eliminated by the concept of introducing the two buffers. Here we already have two buffer scheme means two buffers are to be used for storing that input strings. So for example, here first buffer we come with one of the content with storing some input. For example, int I comma j, for example, semicolon space int. So this is the buffer. Whenever the contents buffer 1 is to be filled, completely filled, buffer 1 contents are completely filled, then it uses a second buffer. It uses second buffer to store the contents. To store the contents, it uses the second buffer. So if the two buffers are also filled, that means the exhausted, then what is the here? The procedure is first buffer. So here my main important procedure is end of the current buffer. That means end of the current buffer means maybe buffer 1, for example. Two buffers are there, buffer 1 is reached. Second buffer, other buffer is filled, buffer 2. Other buffer means buffer 2 is filled. So here also you may get the problem, that is length of the lexeme is longer than the length of the buffer. So here in order to override the buffer 1, we are going to put a separate string in the buffer 2 and then do the process. But in order to do that, the second buffer is also completely filled, then we can go for executing the that is overwritten the contents. For example, in this here buffer 1 contents, int is a separate character wise input string to be processed inside the lexical analyzer phase of the processing buffer input buffering mechanism, and then space I equal to I plus 1. So something like this. So the contents are to be filled. Buffer size is filled. And second equal semicolon j equal to j plus 1 semicolon end of. So here also second buffer filled. So buffer 1 contents are filled, buffer 2 contents are filled. While reading, we are going to make the pointers, that is left gym begin pointer and forward pointer. So first time I read the character I and then move up the pointer, the forward pointer, read second character and read one more character. After completion, third character and then forward pointer space. So here space is considered. Then both the pointers are to be kept at this place, beginning pointer, forward pointer. Whenever space is encountered, no, so automatically we are going to recognize this token. This is a valid token identifier, and then both the pointers will move to the corresponding. So in this procedure, buffer 1 contents are filled, second 2 buffer contents are filled, then override the existing contents of the buffer 1 and then move to the second buffer. In two buffering mechanism, what we are doing, first step is both the pointers we are placing, that is first pointer is called as a Lexim begin pointer and second pointer is called as a forward pointer. So here both pointers we are placing at the beginning of the first character of the first buffer. So previous slide we have seen, this is the first character, placing Lexim begin pointer and forward pointer. So this is the step initially to be processed. Each time reading one character, the forward pointer is to be moved, and then after space is encountered, it identifies that the corresponding lexeme is to be found, and of the lexeme is found whenever the blank space is recognized by that person, by the buffering mechanism. So what is the string that is to be delivered between the beginning pointer and forward pointer? It is to be considered as one token. So previous example we take an int, it is a token, and release and then the corresponding for example, the corresponding token released, first buffer is completed, that means and now the buffer is reached, and then we move to the second buffer. So second buffer is also recognized, and then place the contents reading the forward pointer one time each character by character, and then that is also reached to the end of the second buffer, and then we have to recognize the corresponding remaining characters of that corresponding input string. Then the first buffer is filled, second buffer is, after filling the first buffer, second buffer is to be restart the second buffer filling, and second buffer is also reached end of. So we have used some mark notation, end of file indicates that the buffering, that is the file, is to be completed. There is no further characters to be kept inside this buffering. So that is the sentinel characters which are to be placed inside this one file notation, and later we can identify that both the buffers are filled and the input is stream of tokens is to be identified. So this is called as sentinel characters. This is called as sentinel. So at the end of character, end of file, EOF, and the particular buffer is to be completed or not, placing some sentinels. So it is that buffer is completed, so that we can proceed with buffer 1, or we are at buffer. Suppose that we are at buffer 1, buffer 2, and we reached the sentinel. Then we once again move to the first buffer and fill up the contents of this buffer 1, and we can mark some AOF and verify that whether it is reached. Up to that, we are going to process the input of the remaining characters for the input string, and then the program continues. So here the algorithm which is to be used to recognize the internals are switch. We already know a switch statement. So here each time the forward pointer is moved one position ahead to read the corresponding character. Reading character, each character one position ahead it will move. So while reading this process, so that's why switch case, the first if condition says that if the first buffer is reached or not, it is to be verified, or if the second buffer is reached. So whenever it reaches the first buffer, then we are going to start the second buffer. Second buffer contents are to be placed, and then we are going to reload the second buffer. Suppose we are at the second buffer and we have to reload the first buffer contents, and we have to start the process of initiating first buffer content. So this process is repeated. Into the contents of buffer 1 and buffer 2, and then this is to be supplied with the input strings, and then recognize all the tokens and then releases. So this is called as two buffer scheme. So you have to avoid the drawbacks in one buffer scheme where the length of the lexeme is more than the given buffer size. So it uses a two buffer mechanism where buffer 1 the contents are to be filled and then second buffer to be reloaded, where second, suppose the point is at the second buffer and second buffer is filled and reload the contents of the first buffer. So the process is repeated and override the existing contents of buffer 1 or buffer 2, and then simultaneously the processing input is taken place. And by use of this end of file and sentinels, we are going to skip the input, that is the reaching of the buffers, and then indicates that the particular program is completed. So in this way, we are going to um, recognize the corresponding characters and then the execution of the sentinels to be find out and then release of the tokens. That is the first important phase of the compiler lexical analyzer, where the input is to be recognized, source program instructions, and then that is to be released the tokens. So in between, this is the input and output is to be tokens. So while releasing the tokens, internally it uses the mechanism. What is the mechanism? A buffering mechanism is to be applied and then read the characters and input strings, analyze the tokens and identifies corresponding values, simultaneous informations, and then release the tokens successfully. These tokens delivered by the lexical analyzer used as input to the second phase of the compiler, that is called as syntax analyzer. So in this way, we are going to describe all this one, where the text contents of this slide can be from compilers, principles and techniques, that is Alfred Sethi Willman. So in this, the contents are to be available. So here we are going to discuss a small brief notes on the compiler phases. That is the first phase of the compiler. What is the that is called a lexical analyzer. The role of the lexical analyzer, that means internally it uses a buffering mechanism. It uses a buffering mechanism. Here there are two types: input buffering, one buffering, two buffering schemes. So when there is a drawback with input one buffering scheme, that's why two buffering schemes are to be implemented in order to recognize the corresponding generality of the tokens. So the contents are today discussions. One of the phases, that is role of the lexical analyzer, and second one is input buffering. What is the role of the lexical analyzer? Accepting the tokens, accepting the input program source instruction, release of the tokens. That is the main motto. How it done? By using the concept of buffering mechanism. So input buffering, two buffering schemes, one buffer and two buffer. So in this way, we are going to describe a compiler with the several phases. In this part, first part of the compilation, that is lexical analyzer phase, we discussed, and what is the main role of separating these two phases, lexical analyzer and syntax analyzer. That means there is a more burden, if at all, if you do not divide the phases, two phases. If you combine the two phases into a single phase, then a lot of burden and efficiency, portability, and some of the factors that is to be considered. That is called as compilation. First, simplify design of the simplified. Second, increase of the efficiency. Third, portability. So that's why these two are separated. Lexical analyzer and syntax analyzer phase is separated. Why? Because we are going to simplify the design of the compiler. That means there is no burden to each of the phase, and that's why this is to be separated. Second one is the efficiency of the compiler is to be improved. That means data type and that is the automata recognition, token recognitions, delivering the tokens, and that's why separation after a lot of grammars are all required. That's why. And the portability is whenever the input is to be combined. So to recognize that one is token, a separate syntax is to be identified with the token name and attribute value. So that's why it is to be described as a notation We take an example also, integer, comma, IR, void, main. So each of the character is recognized. After identifying the space, it releases the corresponding token, and the values are to be stored inside the symbol table. So once again, whenever it requires program, it automatically captures that information from the symbol table. So like that, the lexemes are to be identified each of that one and many and places that as a separate. So this buffering mechanism is to be implemented with the two pointers. First one is beginning pointer and second one is the forward pointer. So begin pointer is placing at the same place first character, and after recognizing white space, that means forward pointer each moves one pointer ahead. After reading each character, forward pointer moves one position, and after completing the white space, that means recognizing white space, both the pointers kept aside and releases the corresponding token. So in this diagram, white space identifiers and recognizes the int is an valid identifier. So it places the corresponding information, and then both the pointer will move to the corresponding next position of the character. So like that, all the tokens are to be released. So here in this one, there is some of the drawback is buffer one contents are completed, and buffer size is more less than the lexeme length. Then we have to overcome that point. Two buffer scheme is to be implemented. Two buffering scheme. Buffer one contents are to be implemented with the processing of the input string. Once the buffering one completes, then goes to the second buffer one and buffer two. If buffer one is completely filled, then goes to the second buffer, and second buffer is also completed, then moves the contents from buffer one to buffer two. So the algorithm is to be worked out with the corresponding contents, and the release of the tokens takes place. So this is the main agenda of today's topic. Thank you, and thank you once again, all of you. Once again, thank you. Next class will come with one more new topic. Thank you once again. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.